Hey everyone, Mr. Planetsec here, going through your second video. I decided not to do a little video intro today of me because, frankly, this shouldn't take real long. All right. Hopefully you've been dealing with scientific notation for a number of years now. I just want to do a quick review, make sure we got some things down, and going forward from there. So, why do we use scientific notation? First, scientific notation, a method of expressing very big or very small numbers, right? Sometimes we call it exponential notation, but we usually refer to it as scientific notation. And scientific notation numbers are in the form of x dot yz times 10 to the nth power, right? Now the x dot yz, the x is always going to be some number between 1 and 9, right? And that means that the exponent has to be somewhere between, not the exponent, the coefficient has to be somewhere between 1 and 9.9999 ... as many nines as you can go. As long as it's somewhere less than 10, we're good on scientific notation. So first, let's review the rules. If we want to take a number from decimal notation and put it into scientific notation. First, if we have a big number, a number greater than 10, move the decimal point to the left until there is only one non-zero digit to the left, right? So here, if we take this number, 5,286.2 meters, in order to get that so that there is only one non-zero digit to the left of the decimal, we take this decimal point and go 1, 2, 3 places to the left. So that would be 5.2862. We can't drop any of those numbers. They're still important. We're just writing the same number in a different way. Then times 10, right? But how many places do we have to move it? 1, 2, 3. So that means that our exponent would be 3, positive 3. If the number is between 1 and 9.99999, remember I said that that's what the coefficient on our scientific notation has to be. So if we take a look at this number right here, 6.623, right? There's no need to move the decimal place to get it so that only one non-zero is to the left of the number. It already is. So 6.623 times 10, but how many places do we have to move it? We didn't have to move it any places, so that exponent becomes 0. Hopefully you remember from math class that when we have any number taken to the 0 power, that just equals 1, right? So we end up with 6.623 times 1, which is just 6.623. Does anybody do that? No. Nobody. Why would you write an extra times 10 to the 0 power when you already have a number that's in the right notation? But it is possible we could do it. The other thing we have to talk about is if the number is less than 1, right? If we have a small number. So now we move the decimal point to the right until there's only one non-zero digit to the left of the decimal point. So let's take this number right here, right? 0.0000625. So because this number is less than 1, we move the decimal point to the right. So 1, 2, 3, 4, 5 places. So we start off with our coefficient, right? 6.52 times 10, and we had to move it 1, 2, 3, 4, 5 places, but now we use the negative exponent. So that number in scientific notation would be 6.52 times 10 to the minus 5th. Going the other way, or changing a number from scientific notation into decimal notation, pretty much the same thing, just going backwards. So if we have an exponent on 10 that's greater than 0, we move that decimal place to the right, adding zeros as necessary. So if we, just to be consistent, when we're dealing with big numbers, I should use red. So if n is greater than 0, we move it n places to the right, adding zeros as necessary. So for this number, we need to move that decimal point to the right 4 places. So 5, right? And then if we go 1, 2, 3, 4, 5, right? but we'd have to add zeros in here. Okay, so that number would be 5, 3, and then 0, 0, 0, 0. Okay? No need to keep the decimal point there because of the whole sig digs thing, all right? If you already have an exponent that is 0, you just drop the exponent part. So here we would just go 2.5, okay? If the exponent is less than 0, if it's a negative number, we're going to move the decimal point to the left, adding zeros as necessary. So here, minus 4th power, we move this decimal place to the left. 1, 2, 3, 4. Okay? So we'd write that number as 0, 0, oh, let's see, 1, 2, 3, yep, 0.000723. Does it matter if we write this 0 here? Nope, because remember, any zeros to the left of the first non-zero number, even if the decimal point is present, aren't significant digits. So this one would have the same number of sig digs as the previous number, right? Next, I want to spend a couple of minutes going over some calculator stuff because your calculator knows how to do scientific notation. And if you know how to use your calculator, by default, you know how to do scientific notation. I could go through all kinds of rules about adding numbers and adding the exponents and subtracting the exponents and blah, 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 blah. But I'm just going to teach you how to use your calculator because your calculator knows all those rules, and it's much easier for your calculator to do it. With that being said, let's first take a look. And let's say we want to write a number like 2.56 times 10 to the 15th power. That's the number we're trying to write in scientific notation. I'm going to start with the TI-83 or TI-84. It's the same keyboard. And teach how to use that because most people know that. But I'm going to run through a couple of different types of calculators so you know where to look. All right? On your calculator, regardless of which calculator you're looking for, you're looking for a button that says either EE or E or EXP. Can't think of any other notation that a calculator might have, but it's possible there might be one of those other ones. So if you're looking on your TI-83, if you take a look at the area right above the comma key, all right? The comma key is right above your 7, and there's a little EE written on the face of the calculator. That means it's a second function. So that means you have to press the orange or yellow button, I can't remember what number it is, up in the top left, in order to make that work. So if we want to write that number that we talked about as 2.56 times 10 to the 15th power, if we want to write that in scientific notation, we start off just typing in 2.56. And when you do that, right, that'll show up on your calculator, 2.56. Then you hit the second button. After you hit the second button, you should see a little blinking upwards arrow on your calculator. Then you hit the comma. And when you do, it should look like this on your screen, 2.56, and then that short capital E. Okay? The short capital E, this represents the times 10. Okay? I realize that's yellow, it might be hard to see, but, well, why don't I just do it here? This represents the times 10. Okay? You don't have to write in the times 10. You don't have to write anything else. That E represents all of the times 10. So now it's just time to write in the exponent. So then you type in 1.5 and you end up with a number that looks like this. This notation is how your calculator represents 2.56 times 10 to the 15th. Something I don't want to see. I don't want to see you using the multiplication sign. I don't want to see you using the caret, okay? I don't want to see you using the 10 to the whatever power. I think that's a some kind of base log 10 or something like that, okay? It might work at the beginning when you're doing scientific notation, but eventually your calculator is going to get confused in order of operations. So make sure you learn how to use your calculator properly in scientific notation. The next calculator is a TI 30X, all right? Once again, this is a second function, all right? And there's the little EE right above this character on your calculator, on the face of the calculator. This is the second button. I know there's kind of some glare, and I apologize for that picture. But, so that would make the same thing. So if you wanted to write that number again, 2.56 times 10 to the 15th, okay, 15th, there we go. You would type in 2.56, then hit second and this key here, x to the minus 1, but because you hit the second function, it would come up as EE. And then it's going to appear like this on your calculator. Very similar to the TI-83. Okay? Then you type in the 15, and it looks like that. Okay? And this is how the TI-30X represents 2.5. Oh, hold on a second. Let me do this. Okay? This is how the TI-30X represents 2.56. And then remember, the E represents the times 10, and then we have the 15th power. Okay? So another thing too to remember is if your calculator comes up giving you answers in this format that look like this, that means that it's not 2.56 or not 2.56 times 15, it's 2.56 times 10 to the 15th power. One more calculator, it's a pretty cheap one. I believe it's the one that the state of Ohio gives you when you do your OGT test. Not 100% sure on that, but I think it is. And on this calculator here, you'll notice that the scientific notation button is actually its own button. So you don't have to press a second function like you got here. You don't have to press that red button first. So if you want to do that same number again, 2.56, you type in 2.56 on the calculator, hit the EXP button, and then it sort of looks like this. There's a space. There's no little e in here. The space represents the times 10. And then it comes up as 00. You type in 15, and that 15 will appear over on the side. So the space is representing the times 10. So this is how this calculator represents 2.56. And then remember we said the space represents the times 10, and then you got the 15th power. Okay? So, to finish this up, a couple of scientific notation problems. Okay? Hit pause. Oh, sorry, I thought I fixed this, but apparently I didn't. There is these apostrophes right here. You know what? Let me fix it right now. All right? Those are supposed to be time signs. Apologize for that. When it transferred in from PowerPoint, apparently it didn't fix all that. So, let's fix, oh. Put the X there, and then put the X there. Sorry you had to watch me do that, but had to be done. So, all right, so what you're going to do, press pause, come back, answer should show up. Like it says up at the top, don't forget your sig digs. Remember, when we're dealing with scientific notation, anything that we write in the coefficient counts as significant. Then the same rules apply. So press pause, do the calculations in your calculator, round answers to the correct sig digs. When you come back, answers should appear. And there they are. Hopefully that worked out well for you. All right. Another sheet, another section of problems. All right. Same thing. Use your calculator. Right. Use your calculator. Then write the answer with the correct number of significant digits based on the mathematical operation and the rules that go along with it. Press pause. Do the calculations. Press play. Answers should appear. And there they are. All right, hopefully that worked for you. Hopefully that was a quick review for scientific notation. We'll do a couple scientific notation problems in class on Monday, and hopefully that'll be the last we talk about scientific notation. Talk to you then. Later.